Hi everyone, two questions today. First one from Scott, an integration question, and a trig with a chain rule question from Sarah. Okay, so here we've got the big story about an architectural feature of a building being a wall, there's an arch window in it, and we're looking for the area in square meters of the glass in one window. So we're looking for the area of this curved section. Taking away the whole story, this is the important information. Here's what I've got in terms of my diagram. I'm looking for that shaded area, and that's the equation of the curve that goes above that curved section there. So we're looking for the area between this curve and this line. Okay, if we're looking for the area between two functions or two curves, we're going to be integrating. Okay, important thing to notice is that that line along the bottom there, okay, the line all the way along there, well, that's 1.5 high, so the equation is y is equal to 1.5. Okay, so we're going to need to integrate between the curve of 2x minus half x squared and y equals 1.5, so the upper take away lower. Before we do that though, we need to know what these points here are, okay, because they'll be our limits. And we're going to do that by finding out, okay, when does 2x minus a half x squared equal 1.5? The first thing I'll do here is multiply everything by 2 to get rid of my fraction, so that's going to be 4x minus x squared is equal to 3. And then subtract 4x and add x squared to both sides, so you've got your quadratic equal to 0. And I'll do it that way just so I have a positive x squared minus 4x plus 3. And then just factorize the x minus 1. Oh, I think we're mental today. And x minus 3, which means your two limits of the x is 1 and x is 3. Okay, now what we can do, there's obviously there, probably won't go. Let's do our integral now. Okay, so we're integrating between the top curve, which is my 2x minus a half x squared, and then we're taking away all of our bottom curve, which is just 1.5, so we don't really need to worry about anything there. And that's all with respect to x. My limits are 1 and 3. Okay, now when you integrate that 2x, it's going to be 2x squared over 2, so that's just going to become x squared. This is going to be minus what is now an x cubed over, well, the 2's there, and we've got an additional factor of 3, so it's going to be over 6 minus 1.5x. And all of that is between the limits 3 and 1. Okay, now you've got it integrated, no more simplification to be done. We can just start with subbing our limits. So first we're going to have 3 squared minus 3 cubed. That's it in my head, over 6 minus 1.5 times 3. Subtract the same thing with 1 in it. So 1 squared minus 1 cubed over 6 minus 1.5 times 1. Okay, and just simplifying that when you, I think, I don't know, I presume it's a calculator paper, it might not be, but either way, this is going to work out to be 0, and then we're taking away negative 2 thirds. So your area works out to be 2 thirds, and it's not unit squared because it tells us in the question that it's meters, so 2 thirds meters squared. Okay, so key point, you're looking for an area between two curves. It's going to be integration, upper minus lower, and then subbing in. Just the key thing will be getting the limits first, and you do that just with simultaneous equations. Okay, second question here is this one. Near the gradient of a tangent to a curve is given by dy by dx is equal to 3 cos 2x. The curve passes through the point 7 pi over 6 root 3. Find y in terms of x. Okay, so key point here, you've got the differential. The gradient of tangent, you know the differential anyway, but in there it's telling you that's your differential. If you have your differential and you want to work your way back to y in terms of x, that's working your way back from the differential to your original equation, which we know the opposite of differentiating is integrating. Okay, so y, let's get your pen first. Okay, y is going to be equal to the integral of 3 cos 2x with respect to x. Okay, so to get our original equation, I need to integrate. Key thing here is that 2 means that it's essentially undoing the chain rule, so we're going to have to be careful with our integration to make sure we do it properly. So y is going to be equal cos, from your formula sheet, you know that cos just becomes sine 2x. The 3 is still going to be there. But you also know you need to divide by the differential of what's in the bracket of that 2x. So it's divide by 2 and your plus c will be there. Okay, you have 2 marks there already, maybe 3 if it's a generous marking scheme. One for knowing to integrate, one for integrating. You may get one for the kind of dividing by 2 as well, depending on how generous they're being. And now we need to find out what this plus c is. Now we know in there that your 7 pi over 6, well, that's going to be x, and root 3 is going to be y. So root 3 is going to be equal to 3 sine 2 lots of 7 pi over 6 all over 2 plus c. That's an absolute mess today, I don't know what's going on. So root 3 is going to be 3 sine, if you multiply 7 pi by 6 by 2, that's 14 pi by 6, or just 7 pi by 3 over 2. And 7 pi by 3 is actually, well, that's more than 360, because we know that 2 pi is 360. So 6 pi over 3 is 260. So on our sine graph, okay, there's your 360. It's actually up here. Okay, which we know is going to be the equivalent, exact same value as 2 pi before that, which is going to end up in your first quadrant. So this 7 pi over 3 is really pi over 3, which means that when you're calculating that sine of 7 pi over 3, you're really just wanting sine of pi over 3, which is root 3 over 2. So root 3 is equal to 3 times root 3. We've already got the 2 down there here, but we've got another 2 from the root 3 over 2 plus c. Okay, you multiply both sides by 4, so that will be 4 root 3 is equal to 3 root 3 plus c. And if you take away 3 root 3 from both sides there, c is just going to be a single root 3. Okay, so your final answer is y is equal to 3 sine 2x over 2 plus root 3. That's your final answer there. Okay, so key points there. Firstly, if you've got your differential and you want to get back to the original, you know you're going to be integrating, just integrate as normal. Because you don't have any limits, you've got this extra plus c, but that's fine. You find that and you use a point to sub in and then just calculate what c is. Okay, cheers.